Part A. Express 5x plus 3 over 2x minus 3x plus 2 in partial fractions. So let me write this out first of all. X plus 2. And I'm going to make that equal to a over 2x minus 3 plus b over x plus 2. These are my partial fractions. I need to now work out what a and b will be. So the first fraction, that has to be multiplied by the x plus 2. So I'm going to multiply the a by the x plus 2. The second fraction, that has to be multiplied by the 2x minus 3. So the b has to be multiplied by the 2x minus 3. I can now have a common denominator. Of 2x minus 3x plus 2. And comparing that to the original fraction, I can see that because my denominators are the same, that must mean that the numerators are going to be the same. So I can focus just on this equation here. I'm now going to let x equal minus 2. The reason I picked minus 2 is because I know that that's going to make this bit here become 0. That will then allow me to work out what the b term is. So if x is minus 2, on the left-hand side, 5 times minus 2 is minus 10, plus the 3 is minus 7. On the right-hand side, like I said, the a term, this has just disappeared. And we'll get b multiplied by 2 times minus 2 plus 3, which is minus 7. Therefore, b has to be 1. Now to work out the a term, I focus on what makes this bit become 0. And I see that I'm going to let x equal 3 over 2. So if I substitute that into the left-hand side, 5 times 3 over 2 is 15 over 2, plus the 3 is 21 over 2. That's me just substituting that in here. 5 times 3 over 2 is 15 over 2, plus 3 is 21 over 2. Now to substitute the 3 over 2 into the right-hand side, I've got a times 3 over 2 plus 2. Well, 3 over 2 plus 2 is 7 over 2. And now I can see that a has to be 3. I need to multiply the 7 over 2 by 3 to get 21 over 2. So a is 3. So I can now rewrite my fraction as 3 over 2x minus 3 plus 1 over x plus 2. That's my answer to part A. Part B. Hence, so using what we just did, finds the exact value of the integral from 2 to 6 of that exact same fraction. So I'm integrating what I've just found from 2 to 6 with respect to x. Right, this first fraction, it's 3 over 2x minus 3. Notice that 2x minus 3 on the denominator there is linear. So this is equivalent to integrating a 1 over x function. Therefore, I can integrate it with a logarithm. So I will have 3 lots of ln 2x minus 3 And then, because of the 2 on the inside here, I need to divide by 2 because of the reverse chain rule. The second term is a bit easier to integrate. You've just got 1 over x plus 2. So again, because it's 1 over a linear function, it will be ln. And because it's just a 1x on the inside here, I don't need to worry about the reverse chain rule. I don't need to worry about dividing by anything. Okay, that has been integrated. I am now going to substitute in my limits. So first, let's substitute in the 6. So I'll get 3 over 2 ln 2 times 6. 2 times 6 is 12, take away the 3 is 9. Plus ln 6 plus 2 is 8. So that's me substituting in the 6. Now let's substitute in the 2. So 3 over 2 ln 2 times 2 minus 3 is 1. And ln of 2 plus 2 is 4. Now, one thing to note at this stage, ln1 is just 0. So therefore all of that term there will be 0, and I don't need to worry about that. What else have we got here? We've got the 3 over 2 ln 9. Now I can write 9 as 3 squared, which will be helpful in a minute because I can then move that 2 to the front. ln 8, well, I can write 8 as 2 cubed. And then I've got a minus ln 4, and the 4 I can write that as 2 squared. So now, like I say, just using that power law, just moving that 2 to the front here, the 3 to the front there, the 2 to the front there. 3 over 2 times 2 is 3. Then we've got 3 ln 2 minus 2 ln 2, which will simplify just to be ln 2. I need to give my answer as a single logarithm. So I actually need to combine these 2 logarithms back together to be 1 logarithm. So let me take that 3, put it back here as a power. So ln of 3 cubed is 27, plus ln 2, which is the same thing as ln 54, just multiplying the 27 and the 2 together. And there we go, we have our single logarithm.